Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 48 in the legendary new Arduino tutorials. What we're going to do today is we are going to learn how to connect an LCD display to the Arduino so that you can output your little messages and your little important numbers to a screen. I will need you to get your eLego Super Starter Kit. What? You don't have one? Look down in the description. There's a link, $35. You get the kit that has the Arduino and all the hardware that we are using in this tutorial. Does help if we are using identical hardware, because then what we're doing is exactly the same. I will also need you to pour yourself a huge mug of iced coffee. That would be strong black coffee poured over ice. No sweeteners. No booze, no additives, just strong black coffee over ice. That's all that's needed. Hey guys, I'm also going to give you a heads up of something. Everything that we've done so far in all these lessons has been from components in the eLego kit. And so we've gone a long way here without having to buy anything. There's a couple of things that I just really think that you need in your little toolbox. And one is you need a bigger PC board. Okay, a bigger breadboard. And I will put a link down below, because in future lessons, as we start doing more complicated things, you're going to run out of space on your little existing board here. You can see that even today, should I go ahead and get out of your way? Probably so. I'll go ahead and get out of your way. Even today, you can see that when you put something like this LCD on here, you're starting to use up a whole lot of room. And so as you're getting more complicated projects, you need room to build on. So let's go ahead, let's just bite the bullet, and let's get one of these boards. Link below to Amazon where you can get one of these things. And the other thing that you're going to need, and this is probably overdue, but some of these little jumper wires, it's a little jumper wire kit, and I'll put a link down below for that as well. But it gives you these short little wires. And man, one of the things that I learned in college about a sophomore or junior level is no matter how smart you are and no matter how careful you are, when your circuit starts looking like this, where you have wires going all over the place, and then you get these long ones that are coming in, and then you get these going all over and crossing over. No matter how careful you are, there's just no way to debug this. It just becomes maddening as you start getting more connectors. And so on projects like this, you're always going to have to connect with one of these male-to-male jumper wires from your proto board over to the Arduino. Okay, but all the work that you're doing on the board, you want to use these neat little connectors like this, these neat little jumper wires. As such. Okay, you see very neat little wires, and it makes it much easier to debug things. And also then when you start going to schematics like this, it becomes much easier to connect and to kind of connect like the schematic looks, because really you get to a point that these things just become untenable as far as trying to keep them hooked up right. And so if I were you, we're going to start doing more complicated things in the future. I would go ahead and get a board and get one of these wire sets. And on these wires, you might almost get a couple of boxes of these wires just so that you have what you need, because it makes it so much easier to use these neat, these very neat little jumper cables. Okay, let's go back and let's see what we are doing in today's lesson. So I will need you to get out of your eLego kit, I will need you to get your LCD display. I will need you to get your potentiometer and of course your trusty old Arduino. And then if you don't have these short wires for today's lesson, you're going to have to just go ahead and use these ugly ones. But like I say, as quick as you can, I need you to get these shorter wires. Okay, so to hook these things up, we will be using, where is my, I guess I might still need to add that. Give me just a second to get the schematic. I think I can get this pretty quickly. You know, there's so much stuff going on, it is sometimes hard to keep it all straight. Okay, this is what we're going to hook up, and if you go to toptechboy.com and if you go to lesson number 48, there's a big picture of this, and so you can maybe print it out or have it on your screen big. But I will, in hooking this up, try to go to a view where you can see what I'm working on and see the schematic at the same time. So this looks like a pretty good view where right above my head, and I need to scoot over a little bit. I'm a little bit too much off the screen. And I'm sorry that these things don't just come up perfectly to begin with. That's probably pretty good. Okay, so right above my head is what we're trying to hook up. Okay, and then over my shoulder here, over here, it's hard to point, is the live view. Okay, right here is the live view. So let's see if we can hook this thing up. And I like to, one of the things that you'll see is part of success in projects like this is there's so many wires to hook up, is to try to be methodical and start in one area and then kind of work your way across the screen. And so I am going to start here with the potentiometer. And if you look, you can see that the potentiometer needs to have one leg, which in the case here is the leg on the right. It needs to go to the ground. And so the ground is going to be this negative or blue rail or the second row from the bottom. And so I am just going to get one of these wires and I am going to just jump right in and I am going to bring that to that second row to get me a ground. And guys, if I seem to be struggling with this a little bit, I want to get these wires in where I'm keeping them nice and neat, like boom. You see how neat that is? And I don't want to be bending these little wires because the little wires are in fact somewhat precious. And now one of the things that I'm going to do is if I'm going to use this as a rail, I want to go ahead and hook this up. I'll come over here and then I'll hook it to the GND on the Arduino, because like I say, I want to use this as a rail, and if you're not careful you will forget to make it a rail, and so I'm going to make it a rail. Well, similarly, if that is going to be the rail, the bottom row is going to be the +5, and so I'm going to go ahead and make that +5, and I'm going to use a red wire down to +5. Okay, red wire down to +5. So now I have this as 5 volts, bottom row is 5 volts, and I've got the negative as my ground rail. Also, guys, another thing that I just like to do as much as I can, like the black wire is ground and the red wire is 5 volts, try to use kind of a color code, and as much as I can, I like to try to match the colors of the schematic with the color of the wires I'm doing. Or like if I have an RGB LED, I like the R of the LED to be a red wire. So as much as you can, try to use some methodology in the colors of the wires that you're using. And you can't always do that because like in these little wires that I'm working with here, I don't have the colors that I want and the sizes that I want, so I can't do everything that I need. But next up, I want to connect the other leg, the left leg of the potentiometer, down to the 5 volt rail. And so I will choose a suitable small wire, And that, what did I say? I want to go to the 5 volts. And so that is going to go from there to there. And again, I'm going to fuss with it a little bit to get it to go straight down so I'm not bending those wires. Do you see how neat this is looking here as opposed to this? Okay. This is the same thing as this, but you see it just keeps the wires out of your way, and that's why I really, really like these little things. And also, like these, it's much easier for them to come loose or not be secure, but these are just really secure and much less likely to generate a problem. Okay, the next thing that you can see is that from this center tap of the potentiometer that in this configuration is on the top side, that goes over, if you look at the schematic above, it goes to that first, it goes to the third pin from the right on the LCD display. And, ooh, that came out. The third pin from the right is 1, 2, 3, it's labeled on mine V0. Okay, and so that looks like that I'm going to be pulling the V0 over to the top of the potentiometer. So I bent a wire that would kind of help me do that, I do believe. And I'm going to put it in here to the third one over is V0. Okay, very carefully, 1, 2, 3, V0, and then up to, very carefully, the center leg of the potentiometer. Okay, it's still staying pretty neatly. So at this point, the potentiometer is hooked up. That's really good. The potentiometer is hooked up, so I've kind of got it where I need. I have my positive rail established, and I have my negative rail established. I've got the potentiometer hooked to the LCD. Now at this point, what I want to do is just start working my way across the LCD. And what you can see is this first pin on the right, when you have it like this. Also notice I've got my pins down here at the bottom. And I did that because that's the orientation up here. So my physical workspace is matching my schematic workspace. And to the degree that you can have things oriented the same, yeah, you could have them in any order, and if you were careful, you could do it. But I want to make it as easy as possible. So in the schematic above, what it looks like is the pin on the right, which is labeled, it looks like to me, VSS. The VSS wants to go down to the ground rail. And so I will use a little jumper cable, and I will come in from VSS, if I can get my finger in here, VSS to the ground rail. It is hard to do this on live TV. VSS, okay, boom. You see how neatly that is? VSS to the ground rail. Then the next one over, which looks like it's listed as VDD, it wants to go to the positive rail. And that little yellow one seemed to be exactly the right size. So I'm going to get another little yellow wire. And then I'm going to come from that third wire over, that third pin from the right, and I am going to plug this in. Okay, wow, look at that. Do you see how neat that is? So now I have VSS and I have VDD. Let me give you a heads up that I know that this schematic, that this LCD is going to be upside down when it comes on, but I'm going to build it in this orientation because this is the same orientation that we're doing up here. And then after it's built, then I will spin it around. So I have VSS, which is the first pin on the right, second pin on the right, VDD, and then V0. And now the next pin that I have is RS. And RS is going to come down to pin 7 on the Arduino. And I just want to work my way across. Now, one thing smart they did in the schematic, you see how they're not crossing wires over, that they very deliberately have, as you work your way across the LCD pins, you're working your way across the Arduino pins. Now, you could do it in a different random order, but since you can control what Arduino pin does what, set things up where you're able to get these things where you can just sort of run across. And so now the next pin is RS. Okay, RS is the 1, 2, 3, 4th pin from the right when oriented this way, and that is going to go down to pin 7. Okay, and then I've got, it looks like I'm going to skip 4. 1, 2, 3, 4 pins on the LCD are going to be skipped. 1, 2, 3, 4. And then I come over to D1. Okay, I come over to D1. I think I misspoke there. No. Okay. We got to look very, very carefully. I have hooked up pin 7. The next pin, which on mine is labeled RW, that one also wants to go to ground. Okay, the next one goes to ground. So RW is going to go to ground. I've got this nice little short wire here, and I will take RW to ground. Why is it taking me a second? Because I don't want to bend this little wire up. I want it to be neat and clean. And I think if I go in there, I can pop that in like that. Okay. Do you see that? RW just went to ground. Now I am at pin E, and E wants to go to 8 on the Arduino. So I come from E to pin 8. All right, I'm working my way across the display. Okay, now that I've done E, the next 4 I skip. So I skip 1, 2, 3, 4, and now I come to D4. Okay, and D4 is going to go to pin 9. D4 is going to go to pin 9 on the Arduino. And then D5 is going to go to pin 10 on the Arduino. Now you see I'm just kind of running across here. And now D6 is going to go to pin 11 on the Arduino. And then finally D7 is going to go to pin 12 on the Arduino. And now if you look at this, the nice thing is if we're going to try to debug this, the one thing is I use too long of a wire on the 10 connection. So I'm going to come and get a shorter wire. I like to use as short of wires as I can. And then through my design and through my fabrication, I try to limit the number of times wires are crossed over. So what do I like about this? You see how these wires are not crossing, so it's relatively easy to debug. I just look on the schematic and I see that 4 in the middle were skipped, and then I look here physically, 4 there were skipped. And so this is really looking like a pretty neat build. But I am not done yet, because the second pin from the left wants to go to VCC. And I did that very nicely. It wants to go to the 5-volt rail. And I did that very nicely with one of those little yellow wires. So I'm going to get that, and then, sorry. Okay, I'm going to go then. The second pin from the left will give me a connection to that bottom power rail. And then this first pin on the left, when oriented this way, that guy wants to go to ground. And so I think I can do that with one of these little orange ones. So that is going to go there to there. And then look at that. That is lighting up, which is a good sign that it's like showing some signs of life. Okay. And then what we'll want to do is we will end up having to adjust this potentiometer until we can see the things that we're displaying. Nothing is displaying yet, so don't be alarmed. But if you come too far this way, you're going to blow it out where you can't see it. And then if you go too far this way, so you've got to adjust this until it shows up nicely. Okay, I am hoping that we have this all hooked up. So let me go back and look and see. It really looks like I have got everything connected at this point. All right, so at this point, I think we are ready to code. I'm going to move this over so you can see that that is connected. I'm going to try to get it all in your view. Okay. Take a second to get this where you can all see it well. All right. Now, what do I know? I know that I connected it according to the schematic, but I know that the text is going to be upside down. So now that things are connected, I'm showing a lot of confidence to move to my programming orientation from my wiring orientation before I really know I have it wired up right. But I think we were pretty careful. All right, so now we need to start coding. And we are going to start coding together. So I will need to here go to a good code view. So what would be a good code view for you all? I have so many different possibilities here. I think this one will be pretty good. Okay, so I took the schematic down. And I'm showing you a live view. Okay, let me just adjust this. I don't like this exactly like this. Okay, so you've got two live views, and then also I might move a little bit more out of your way there. Okay. All right, I hope you can see everything there. I think you can. Okay, so let's start coding. We are using the LCD, so we will need to load the LCD library. And so how do we load a library? Pound include, and then open triangular, and the library that you will need, which if you installed the Arduino IDE with us in lesson 1, you will have the library. You just got to load it here. It is liquid crystal. Good thing it recognizes that. H, and then end your end triangular. And remember, loading a library is one of the few steps where you don't put a semicolon at the end. Okay, now we've got to go in and kind of define those pins in our schematic. And if you will watch this, you hopefully will recognize that this is the way that we hooked it up. The pin on the LCD called RS, we connected that to 7. The pin that was called EN, we connected that to 8. Remember how we just came across int? And then we had D4 was connected to pin 9. And then int D5 was connected to pin 10. And then int D6 was connected to pin 11. And then int D7 was connected to pin 12. All right. Now you could, when you set up this liquid crystal object, you could, instead of using variables, just put a bunch of numbers in. But I like to use variables because then I'm checking my code has some physical tie in the real world to my circuit down here. Does that make sense? All right, now we need to, up here at the very top, we need to go ahead and create our liquid crystal object. And so we're going to call the library liquid crystal, and then we're going to name our liquid crystal. I'll call mine LCD. And then what it wants is it wants the RS pin, which we have a variable RS, the EN pin, the D4, the D5, the D6, the D7. That's how we tell the liquid crystal library in the Arduino how we've connected it so it knows what to do with which pins. So that should create the LCD object. And then what we are going to do here is in the void setup, we have to start the LCD. So we do an LCD.begin. And what do we have to do? We got to kind of tell it what kind of LCD that we're working with. Our LCD has 16 columns and 2 rows. And so you tell it that with 16, 2. I can't tell you how bad that bothers me, because as a math teacher and with matrices, it's always R by X, row by column. But they chose here to put the column first and then the row. So 16 columns, 2 rows, what can you do? I guess you can have some coffee. That's all we do. So we set up the pin, we loaded the libraries, we set up the pins, we created the LCD object, and then we started the LCD object. Now, what do we do here? Well, the first thing that you have to do to print to the LCD, the first thing that you have to do is you have to tell it where to put the cursor. And while we said that it was 16 columns and 2 rows, you've got to understand that the upper left, where you would want to start, the upper left is 0, 0. So this is counting things as 0. So the first row is row 0. The first column is row 0. So we've got to say to put the cursor there. So we say lcd.set cursor, and then we are going to put it at 0, 0. Okay. And then we're going to do lcd.print, and then what are we going to print? Hello world. Okay, like that. So we put the cursor at 0, and then we say lcd print hello world. Let's download and see what happens. Ooh. Okay, now it seems that nothing happened, but what do we have to remember? Perhaps we need to adjust our potentiometer a little bit. Okay, here in this orientation, if I turn it all the way to the left, it is too dim, and so I'm now gradually turning it to the right. And as I gradually turn it to the right, I see hello world. Boom! Did you see that? Giddy up. We got hello world on here. Now for me, I want it a little brighter. Okay, I want it a little brighter. But you see, if I go too bright, I start getting some background interference. And so I am going to turn it right about like that. You guys are looking from straight above. It sort of matters what angle you're looking at this, but for me, that looks perfect, just like that. Okay, there we go. We have a hello world. All right, so now let's just start playing around with it. And let's say that, what if I wanted to come down here and say hello world, LCD print, and say my name is Paul. Okay, so we're sending strings, right? You see that? We're sending strings to it. And then I come over here and let's download that. Okay, so look at that. What happened if we look at this closer? What happened? Hello world, my name, and then it went off the edge of the LCD. What you're going to find out is the LCD is sort of not very smart. Okay, the LCD is not very smart, and so if you run it off the edge, it will just allow you to run it off the edge. So what I want you to tell me is, what would you do in this situation? What would you do? Well, what I might do is I might come in and say lcd.set cursor, and then I might say, let's go back to 0, 0, all right, and let's put a delay in here. Let's say, let's just go like this and see what happens, all right? So we're going to download that. I'm sorry, you didn't see what I was doing. Let me come back to code view. Where was our good code view? A good code view. Man, I need to delete some of these old shots. I get so many shots. Okay, here was the code view we were using. Okay, so what I did was I said set cursor 0, 0, LCD print hello world, LCD set cursor 0, 0, and then LCD print my name is Paul. And what I was trying to do there is I was trying to not run my name is Paul off the edge of the screen. And so now what we end up with is my name is Paul hello world, and it's just like going like this so fast you can't see it. So what do I need in here? I need a delay. Okay, delay, let's put 1,000, and I forgot that you can't see that, so let's put a delay of 1,000. Okay, and then LCD print my name is Paul, and then delay 1,000. Okay, like that. And now let's download that, and what you see is hello world, my name is Paul. Hello world. Okay, now what is the problem? It almost worked. Hello world, my name is Paul. Hello world, my name is Paul. But what's the problem? That what I left from the original my name is Paul, hello world, set the cursor back to the start, but then it left the trash out there. So what do we need here? We need to do an lcd.clear like that. So it's going to say hello world, and then it's going to say my name is Paul, and then it's going to erase everything and go back to hello world, and that way I won't end up with the Paul hanging out there. So let's try that. Okay, hello world, my name is Paul. Hello world, my name is Paul. Hey, that works pretty good, doesn't it? So guys, the first thing you need to do with the LCD is you just need to go in and you need to connect it and print hello world, and that shows you that your circuit is working. Now if you have a problem after your circuit is working, then what you need to do is you need to go in and you've got to be very mindful and methodical in doing your coding, because like, let me give you another one. Okay, so let's just come in and say I really don't want to have two lines. I just want to go back and say hello world, and so I don't need these delays. I'll just take them out, and I'm just going to do a hello world. I'll set cursor hello world and then clear. All right, let's see what happens there. And so I will come back over here. Okay, uh-oh, I can't hardly see hello world, and it's all glitchy. What is wrong? Why is it doing that? And a lot of times if you see this behavior, you're doing something like this. Okay, I say hello world, clear, hello world. Is this going fast or slow? It's going really, really fast. So as soon as hello world is on there, I immediately clear it. Your eye doesn't have a chance to see it. So I need a delay. So let's put in a delay of 100 so we have time to see it. Okay. Now it's not working at all. Okay, so I want you to look at this and tell me what I did wrong. Okay, do you see it? I say hello world and clear immediately, and then I wait. Okay, what's wrong with that? Waited in the wrong spot. So I am going to cut that. So I want to put it on my display, I want to pause and then clear. Voila! Perfect. Perfect. Okay, in the first example, what I did was I went hello world and then my name is Paul. Hello world. What was I not taking advantage of? I wasn't taking advantage of there's a second line that I can work with. And so here I'm going to take these out for right now, and then I'm going to say I printed hello world. I'm going to go to the second line, lcd.set cursor, and then I'm going to go to column 0 and row 1 as such, and then I will print that, and then I will delay for 100, and then I will do an lcd.clear. And I always like to do the lcd.clear, otherwise it just seems like you're going to end up somewhere with something you didn't expect. You know what I forgot to do? I forgot to put my second line in there. lcd.print, and then my name is Paul. All right, like that. Okay, you see, look, that looks really good. Now let's say we wanted to do something different. So I'm going to come up here and I'm going to say, watch me count. Okay, and then I'm going to say watch me count, and then I'm going to go to the second row, and then I'm going to say 4, and I don't want to go all the way to the top to declare a variable for my counter, so I'm just going to do it here. You can do it here. Really, I don't like doing this, but I'm going to do it for int j is equal to 1 to j to j is less than or equal to 10. What's it's going to do? It's going to count to 10, and j is equal to j plus 1. All right. Now what am I going to do in here? I'm just going to print j. Not print, I'm going to do lcd.print j as such. How's that? Now let's run it and see what happens. Okay. Watch me count. Okay, what is wrong? It's counting across the screen. It is counting across the screen. So what do I need to do? You see, it says 1, 2, 3, 4, 5, 6, and then it goes across the screen, and you can't see it like that. Well, what do I need to do? Every time when I print inside this loop, I need to do lcd.set cursor, and I need to go to column 0, row 1, like that. And if I'm going to do it inside the loop, I don't need to do it outside the loop. So now let's see what happens. Okay, so why is all I'm seeing is 10? What's the problem? The problem is, my friend, the problem is that it's counting so fast that you can't see it. So I need to put a delay. Well, where do I need to put a delay? I need to put a delay inside the loop. So let's go like half a second. See how that looks. Okay. 1, 2, 3. I can watch that. That's pretty good, huh? Uh-oh, what's wrong now? The second time through, I still have the what? I still have the 0 because I didn't what? I didn't clear the display. So you see, I'm deliberately making these mistakes so you can see what to do. So what do I need to do? lcd.clear, like that, right? Okay, so let's see what happens now. Didn't get anything. Okay, you tell me what's the problem is. Pause it and you figure out why I don't have anything at all on the screen. Because guys, I teach people all the time, and this is over and over and over, this is where you end up. So the thing is, you've got to figure out what the problem is. Pause it and figure out what it is and make it work. Okay, if you figured out what it was, leave me a comment down below. What is the problem when I do this LCD clear in the loop? It clears everything, including the watch me count. And then what did I do? I cleared right after the print. So that's why the second line is gone. So one thing I could do, like you might say, okay, well, let's put it after. Let's do the clear after the delay. Now let's see what happens there. Watch me count. Now watch me count has disappeared, but at least the second line is working. Why did watch me count disappear? Well, because I put LCD clear inside the loop, and that's going to clear out this. Okay, so what do I need to do? I need to put the clear outside the for loop. Okay, so what's it going to do? It's going to say watch me count. It's going to count the first number, the second number, the third number, and then when it drops out of the for loop, then it's going to clear. So let's see what happens there. Watch me count. Boom. You see, it's working now. Guys, I hope you're really figuring this out on your own. I hope you're figuring this out on your own, because what I see is there's people that never get past the point of finding a demo on the internet and copying the code and copying the circuit and hooking it up, and as long as everything is exactly the same, it's working. And when they do things on their own, it doesn't work. And then rather than digging down and figuring out what went wrong, they just give up and they go to another project until they can copy something that works. What I want you to do is start getting good at debugging your code, at troubleshooting. What could be wrong? Well, things that could be wrong. Things that could be wrong are maybe you did not hook things up right. Okay, there could be a wiring problem. Well, that's why when you wire up something this complicated, before you jump in and start doing a very hard and difficult program, just do the simple Hello World program to see. The code's very simple. See if you are talking to the LCD and if the LCD therefore is hooked up properly. If the LCD is hooked up properly, you can kind of rule out the wiring. If the simple Hello World problem doesn't work, then you've got to go in and check that you have everything connected together correctly. If you're absolutely positively sure that you have it connected correctly, then you've got to start thinking about things like a loose connection or a bad wire. Like, what if this red wire were bad? All of a sudden it doesn't work. Now you saw that I unplugged it, but it would be the same thing if the wire was broken. You would get this effect. Well, what would you need to do? You would need to go in and start taking parts out and replacing them with other parts. And I will tell you, one of the things that I see happening sometimes, with students is that the LCD can actually be burned out, and so there comes a time that you have to take the LCD out and put a different LCD in, and you say, well, the different one still doesn't work. Well, maybe it's a wire, or maybe my breadboard. But what you have to just convince yourself of is if you do it right, it will work. It will work. And if it's not working, it's because something's wrong, and you've got to get to the bottom of it. Okay, well, now if you can make the Hello World work, but the more complicated things don't work, then what you got to do is you got to go into the code and start debugging your code, because you could see, man, you know, you're going to live or die whether you put that LCD clear in there and whether you put it in there in the right spot or not. Because if you put it before the delay instead of after the delay, all you're going to see is a blank screen. So isn't it funny that the blank screen of death could come from a bad wire, Or you could get the exact same symptom by putting the LCD clear before the delay instead of after it. So you see, I'm just talking you through this because more important than you knowing how to hook up an LCD, more important than knowing how to hook up an LCD is you knowing how to troubleshoot a circuit. And troubleshooting a circuit means it could be something on the breadboard at the circuit level, or it could be something in your Arduino code. Does that make sense? I think this is pretty exciting because really at some point on Arduino we want to break away from just sitting here with the serial monitor and the keyboard. At some point you want to kind of become untethered, and one of the first steps in becoming untethered with a Arduino project is to have a display. Okay, you have a display, and the other thing is you want to be able to power your Arduino in your project with something other than the USB cable. But one of the things that I hope people understand is at this point, all this USB cable, once I've downloaded the program, all the USB cable is doing is giving power to the project. I could unplug this and plug a battery bank into it, and it would be operating on its own at this point. So we're trying to become untethered. First thing is we've got a display going. Second thing we'll do at some point in the future is we'll disconnect this and plug in a portable power supply. And then the third thing that we'll finally do is we'll need some sort of input. So maybe we'll have to have a little portable keypad, or maybe like if we were doing something like a GPS or temperature sensor, all you would need is the sensor, the display, and then power. So that's kind of the direction that we're doing. Again, you guys, future projects, you need to get this wire kit, and future projects, you need to get this board. Because imagine at some point, if we're going to do something like a GPS, we're going to want to go beyond these jumper wires, and we'll probably want to get like an Arduino, like a smaller Arduino that we can plug onto the board, and then the components on the board, and then the whole thing is on here with these nice little wires. And so that's the direction that we're going, so we get something that really starts looking a little bit more like a prototype as opposed to just a proof of concept breadboard. Okay, what is your assignment for next week? Your assignment for next week is to build a calculator. Okay, you are going to build a calculator using your LCD display. The calculator should prompt you on the LCD, please enter your first number. Then it's going to prompt you, please enter your second number. And then it is going to prompt you, what operator do you want to do? And the operators would be plus, minus, times, or divide. And then I want nicely formatted output. So like if it says, what's your first number? And you say 3, and then you say, what's your second number? And you say 4, and you say, what's your operator? And you say plus, and then the screen just says 7. No, you want to put the answer like, the answer is, and then you would say 3 plus 4 equals 7. Does that make sense? So you're interacting with it through the screen, and yes, you will still have to do the keyboard. I will give you a hint. In order to do this, you have to know how to use the LCD screen, which you've learned today, and then also you're going to have to know how to input numbers from the serial monitor. Remember how you do that? You have to ask, wait, read. If you're going in order through these lessons, you know how to do that, but I will give you a hint that that is lesson number 18. So you're going to have to know how to do lesson number 18, which is reading numbers from the serial monitor. And also, when you ask for the operator, add, subtract, multiply, or divide, which might be like plus, minus, and the little star for times, and then the slash for divide, that is not a number, that is a string. And so you are going to need to know how to read strings from the serial monitor, and that is lesson number 19. Okay, before next week, you guys need to do that project, and then we'll come back next week and we'll do it together. But really, guys, there's the difference between the men and the boys, the difference between real engineers versus little wannabes in their mom's basement is the ability to do things on your own, because nobody's going to pay an engineer to do something that could just be copied and pasted from the internet. You've got to figure things out. You've got to develop a strategy. You've got to develop it. Then it doesn't work, and you've got to figure out what was wrong. And you're never going to be anybody. You will never be somebody unless you start doing these things on your own. And maybe you like just watching my videos and copying what I'm doing on the screen, and that's fun, but you're never going to be somebody unless you can go out and do these things on your own. And the problems that you will encounter and the debugging and troubleshooting skills you will develop on simple little things like this will then be the same ones that you will use when you're developing a hypersonic missile or a SpaceX re-entry booster thruster firing program. It's all the same. But you've got to develop the ability to develop a strategy, do a project on your own, and then debug it. Okay, so that's why I want you guys to work on these homeworks on your own. All right, this has been fun. I am Paul McWhorter from TopTechBoy.com. I will talk to you guys later.